Ever wondered what powers the world around you? From your smartphone to the city lights, it all starts with electrical and electronic engineering. And I've always been fascinated by how things work. Not just in a "oh, that's neat" kind of way, but in a "I want to take this apart and see its soul" kind of way. And the soul of almost everything we use today is electricity. It's this invisible force, this magic that we've managed to bottle, and EE is the language we use to speak to it. It's the art of turning a bunch of wires, components, and a little bit of code into something that can change the world, or at the very least, make a really cool desk lamp. For me, choosing to study EE wasn't just about getting a degree, it was about getting a superpower. It's the power to understand the fundamental building blocks of modern life, and the ability to create things that have never existed before. It's like being handed a toolbox filled with lightning bolts and circuit boards and being told, "Go on, build something amazing." It can be intimidating, sure, and there will definitely be moments where you accidentally let the magic smoke out of a component. We've all been there. But the thrill of finally getting something to work, of seeing your idea come to life, is absolutely unbeatable. So if you're someone who looks at a gadget and immediately wants to know what's inside, or if you dream of building things that solve real problems, you're in the right place. This isn't just another boring lecture about a college major. This is about finding your passion and figuring out how you can leave your mark on the world. Together, let's explore why EEE could be the perfect path for you. Okay, let's get real for a second. What do your phone, that Tesla you saw the other day, and the entire power grid have in common? It's not just that they're cool. Well, they are. It's that they are all fundamentally powered and controlled by the principles of EE. It's the invisible architecture holding up our entire digital world. Think of it like this. If technology were a giant sprawling city, EE engineers would be the ones who not only laid down every single road, power line, and communication cable, but also designed the traffic lights and the power stations that keep the whole thing from descending into chaos. It is the absolute, non-negotiable foundation. When you start studying EEE, you begin to see this foundation everywhere. Suddenly, a simple remote control isn't just a plastic box. It's a miniature transmitter sending coded infrared signals. Your laptop isn't just a screen. It's a complex dance of microprocessors, power management ICs, and data buses, all working in perfect harmony. It's like learning to read the matrix. You stop seeing just the surface-level function and start understanding the intricate, beautiful logic underneath. And that's where the real fun begins. Because once you understand the rules, you can start bending them, breaking them, and making them do new things. This isn't just about understanding existing tech. It's about building the next wave of it. The skills you learn are the very same ones that are driving innovations in renewable energy, creating smarter and more efficient solar panels and wind turbines. They're the skills behind medical devices that save lives, the satellites that connect our planet, and the robots that explore new worlds. EEE isn't a static field. It's a living, breathing discipline that is constantly pushing the boundaries of what's possible. It's the engine room of progress, and you get to be one of the engineers at the controls. All right, let's talk about the super practical question that my parents definitely asked me. But what kind of job can you get with that? The answer is honestly almost anything you want. I used to think EEE meant you either worked at a power company or you fixed TVs. I could not have been more wrong. The reality is that because electricity and electronics are in everything, EEE graduates are needed in every industry. It's one of the most versatile degrees you can possibly get. You become a universal problem solver, and companies love that. You could be designing the next generation of processors for a tech giant in Silicon Valley, or developing the guidance systems for a rocket at SpaceX or NASA. You could be in the telecommunications industry, building out the 6th generation networks that will change how we connect with each other. Or maybe you're passionate about music and want to design audio equipment and synthesizers for a living. Even industries you wouldn't expect, like finance, hire EEE grads for their analytical skills to develop high-frequency trading algorithms. The list is insane, and it just keeps growing. What this means is you don't have to have your entire life figured out right now. Studying EEE doesn't lock you into one specific path. It opens up 1,000 different doors. You can pivot, you can explore, and you can follow your curiosity wherever it leads. One year you might be working on consumer electronics. The next you could be consulting for a sustainable energy startup. The core skills of circuit design, signal processing, and systems thinking are so fundamental and in demand that you become incredibly adaptable. It's a career field with built-in freedom and flexibility. This is my favorite part. EEE is not a spectator sport. It's not about sitting in a lecture hall and just memorizing equations from a dusty old textbook. It's about taking that knowledge, walking into a lab, and making something real. It's about the smell of solder and the quiet satisfaction of a circuit that actually works. This is where the theory smashes into reality, and honestly, where reality wins in the most hilarious and frustrating ways. You will build things that fail. You will build things that smoke. You will build things that do absolutely nothing at all. And you know what? It will be the best learning experience of your life. Every project, whether it's a simple blinking LED or a complex autonomous robot, is a puzzle. You have a goal, a box of components, and a brain full of theory. Your job is to connect them. This process really forces you to think critically and creatively. Why isn't this working? Is my code wrong? Did I wire the transistor backwards? Is the power supply even on? Debugging a circuit is one of the most powerful problem-solving workouts you can imagine. It teaches you patience, persistence, and a methodical approach that you can apply to literally any challenge in life. And the feeling when you finally solve it? It's pure magic. The moment your motor spins for the first time, or your sensor gets a correct reading, or your code executes flawlessly, it's such an addictive rush. This hands-on, project-based learning is what makes EEE so powerful. You're not just studying to pass an exam, you're building a portfolio of things you have created from scratch. You're developing an intuition for how electrons flow and how systems behave. You're learning by doing, by failing, and by doing it again. And that's how you become a real engineer. It's easy to feel a little helpless about big world problems like climate change. It all seems so massive and out of our control. But here's the thing. EEE is right at the heart of the solutions. If we're going to transition to a sustainable future, we need engineers who can design and build the technology to make it happen. We need people who understand power systems, energy efficiency, and smart technology. We need electrical and electronic engineers. This field isn't just about making cool gadgets. It's about making a tangible, positive impact on the planet. Think about green energy. Making solar panels and wind turbines more efficient is a classic EEE challenge. It's about materials science, power electronics, and control systems, but it doesn't stop there. How do you store that energy for when the sun isn't shining or the wind isn't blowing? That's a battery technology and power management problem. How do you integrate all these renewable sources into our existing ancient power grid without everything collapsing? That requires building a smart grid, a massive EEE project involving sensors, communication networks, and sophisticated control algorithms. Beyond just energy, EEE is driving sustainability everywhere. It's in the creation of ultra-low power electronics that make our devices last longer and consume less energy. It's in the development of smart infrastructure for cities, things like intelligent traffic systems that reduce congestion and pollution, and smart buildings that optimize heating and lighting to slash energy use. By choosing EE, you're not just choosing a career. You're gaining the skills to be an active participant in building a more sustainable and climate-conscious world. You get to be part of the solution, one circuit at a time. One of the coolest and maybe most underrated things about EEE is that it speaks a universal language. Ohm's law works the same in Tokyo as it does in Toronto. A transistor functions identically in Berlin and in Brazil. The fundamental principles of electricity and electronics are global truths. This means that the knowledge and skills you gain are not just valuable in your hometown or your home country. They are respected, understood, and in demand all over the world. Your EEE degree is basically a passport to a global career. This opens up a world of possibilities that goes far beyond just travel. It means you can collaborate on international projects, working with teams from different cultures and backgrounds to solve global challenges. You could find yourself working for a multinational corporation with offices on every continent, or joining a research project at a prestigious university overseas. The problems we're trying to solve, in energy, communication, computing, and healthcare, are global in scale, and so are the teams of engineers working on them. Whether you dream of living abroad or simply want the security of knowing your skills are transferable anywhere, EEE provides that. It connects you to a global community of makers, innovators, and problem solvers. You'll be able to read a schematic from anywhere in the world and understand exactly what it's supposed to do. This global relevance gives you incredible freedom and security. It ensures that no matter where you go, your ability to understand and build the technology that powers our world will always be one of your greatest assets. So, we've talked about how EEE is the backbone of everything, how it gives you a ton of career options and how it lets you get your hands dirty, building things that can actually help the planet. It's a field that's as creative as it is analytical, as hands-on as it is theoretical. It's a challenge for sure. There will be late nights confusing schematics and projects that just refuse to cooperate. But the reward is understanding the secret language of the modern world and having the ability to write your own sentences with it. For anyone out there who feels that spark of curiosity, who wants to do more than just use technology, I really encourage you to look deeper into EEE. Don't be intimidated by the math or the complexity. Every expert was once a beginner who probably fried their first few components. The journey is about learning, building, failing, and learning again. It's about the joy of creation and the power of turning an abstract idea into a functioning reality. It's a field for the curious, the persistent, and the people who want to build the future, not just wait for it. The world needs more builders, more problem solvers, and more people who understand how things really work. It needs people who can harness the power of electricity to create a smarter, more connected, and more sustainable world. Why EE? Because electricity powers the world, and EEE engineers are the ones who control it, improve it, and innovate with it. Don't just study technology, build it. Start your journey in EEE today.